Writing equations of lines from a graph. So we're going to switch up. In the past, we have been given an equation, and then we use that equation to sketch a graph that represents the equation. Now we're going to look at a graph like we have right here, and we are going to write a possible equation. There are actually many equations that we can write that would represent this given line. To review, I want you to scroll down to slide down to the bottom of our page here. These are the 4 equations that we have learned already. Y equals m. Remember that m always represents slope, which is the same thing as rise over run. We've also talked about it as the change in y over the change in x, or you can think of it as the vertical change over the horizontal change, the up and down change over the right and left change. And then x1, y1 is any point on the line. And the thing that we have to remember is there is a negative in our equation, which makes it the opposite of, so what we have here in the ordered pair is the opposite of what you see in the equation. And remember, the reason that is it's made by picking the opposite. It makes this parenthesis, what's here is 0, and anything times 0 is 0, and that leaves y1 as the coordinate, the partner coordinate. When we're looking at slope-intercept form, we still have m, which is the same slope, same thing here. And it just tells us B is a specific point. It is a point on the line, but it's a specific point, and it's the y-intercept, which is where y-intercept, which is where the graph crosses the y-axis, where the line crosses the y-axis. I want you to pause the video and write down the coordinates for A, B, C, and D. So hopefully now you have your points written like here, and if not, please label your graph. The next piece of information that we need to have in order to write an equation, so we have the point, now we need the slope. So I want you to pause the video and mark the slope on your graph. Count up rise over run. You should hopefully have your slope as 3. And just, you can start anywhere on here. If I go from B to C, it's still up 3 over 1, up 3 to the right 1. And I wanted to point out that it doesn't matter whether you go from the left or to the right. You just need to keep note of your direction. So if I'm going up 3, that's a positive 3. If I'm going to the right 1, that's a positive 1. So that's positive 3 over positive 1, which reduces to 3. If you are looking at, if you started up here, so if I started at B and I go down 3, that's a negative 3. And so that's going to be negative 3 over, and then from there to get to the point, I have to go left 1. So that's a negative 1. And so negative 3 over negative 1 still reduces to 3. So between any 2 points, when you reduce your fraction, you will get the same slope. So the slope that we're going to use for this line, because the slope of this line is 3. Now we are ready to write our equation, but I don't want you to have to write all of an equation for each one of these points, and so I'm going to assign a point to you based on your name. If your name starts with letters A through G, then you're going to use this point, point A. If your name starts H through M, you're going to use point B. If your first name starts with letters between N through S, you're going to go to point C. And if your name starts with a T through Z, you're going to use point D. So pause the video right now and use the slope in your assigned point to plug into point slope form. I'm going to show this first one. So you have the equation y equals m. Well, our m we said was 3 times the quantity x minus x1. Well, x1, our x coordinate is negative 2. And if you subtract negative 2, x minus negative 2 is the same thing as x plus 2. You could write that as x minus a negative 2. You just don't see things written that way, but that would be technically correct. And then plus negative 4. So you could have that as plus a negative 4 we have right here, or if you're adding a negative, that's the same thing as subtraction. And so we would have it written like this. And we'll check the rest of these. So check your answers with what I have on the screen. And let's talk about this. So these all look different, but how can they represent the same line? And what we're going to do is we're going to simplify these. And I'm going to start with this, with line C right here, noting that the point 0.02 is also considered the y-intercept because it's where the line crosses the y-axis. And so when you have x minus 0, that's just the same thing as x. So we have y equals 3x plus 2. And I hope you will recognize that this is the slope-intercept form of the equation because we've used that specific point of the slope-intercept. I'm going to take a minute to simplify the rest of these to show that if we simplify these, we're going to come up with the same equation. When you're giving me your equations, you don't have to simplify each time, but just because we all did different equations, I want you to see that these are exactly the same. So you can see that if I distribute the 3 times x and 3 times 2 gives me 3x plus 6. I had the minus 4 from the outside, plus 6 minus 4 gives me 2. This is the same equation as our slope-intercept form. If I distribute the 3 here, 3x plus 3 minus 1, simplify, get the same equation. This happens for all of them. So these are all different forms of an equation that represents this line. But we could have stopped right here and left it in point slope form for any one of these. Or we could have given slope-intercept form. So what information is needed to write an equation of the line? Pause your video and write it right there. Hopefully you have slope and a point.